What's up, kids? Mr. Murray here on Mr. Murray's Mathland, and today we're taking a look at inverse functions, specifically derivatives of inverse functions. So it's going to use some properties of inverse functions that you learned in pre-calculus and Algebra 2, and put them together with derivatives, which is what we're working on in calculus. So given h of x is x squared minus 6x plus 3, and for the domain x is greater than or equal to 0, if f of h of x equals x, find f prime of 10. Now, first of all, finding f prime of 10, it would be great if we had the equation of f of x, because then I could easily take its derivative, f prime, and then just plug in 10. But nowhere in this problem do I have an equation for f of x. So one thing right off the bat that you may be a little rusty with is that this right here, this composition property, the fact that f of h of x is equal to x, that means they are inverse functions. And think about, inverse functions like squaring the square root of x leaves you with just x, or the natural log of e to the x equals x. Those are inverse functions, and they undo each other, if you will, to leave you with x. So when you see this composition property giving you x specifically, the fact that it's worked out to be x, that means they're inverses. Okay, so that's one old review property that can help with this. The other thing is now knowing, well, what's the connection between derivatives of inverses? I'm looking for f's derivative at 10, and now I know that f is the inverse of this function. Well, one thing you might remember is that on inverse functions, x and y are switched, right? And so you could try to write the inverse function of this, which would be f, by switching x and y, right? Making this x equals y squared minus 6y plus 3, and then trying to solve for y, and then, and then plug in 10, but that's going to be a little messy too. So I've intentionally chosen something that's that way. So you learn this calculus property. Now this property, this rule actually comes from doing the derivative of this composition right here, if you will. So if you ever forget this rule, this is where it's derived from. If you have f of h of x equals x, and you take the derivative of that, using your chain rule, you'd get f prime of h of x times the derivative of the inside, which is h prime of x, is equal to derivative of x is 1. And then by solving for h prime, you get 1 over f prime of h of x. And so there's the connection here, that the derivative of 1 is the reciprocal, 1 over the derivative of its inverse of h of x. And this could easily be written the other way around as f prime is 1 over h prime of f of x, since that's the one we're really looking for. So now that we got some of that stuff out of the way, let's really get down to business here for this particular problem. I like to think about it this way. Like if I'm looking for f prime of 10, now you might be good enough and comfortable with your function notation to say, okay, then I'm looking for 1 over h prime, and h prime is something I can write, of f of 10. But the first thing you have to find is, well, what's f of 10? And you don't have f's equation. So what you need to realize is that, 10 being the x value on f makes it the y value on h. So this is what I'd call sort of the inverse coordinate. So I will frequently set up my problems like this. If what I'm really looking for is f prime of 10, and I can't get there directly, there's really a couple things I got to find first. I call this sort of the loop, kind of like a detour, since you can't get directly there. The first thing you want to say is, well, on the other function, which in this case is h, that means 10 is the y value. So I'm taking my x value that I care about and making it the y value on h. And now I want to find out Well, when is that the case? When is 10 the y value on h? Finding the inverse coordinate. So that's where I'm going to take my h of x here. And set it equal to 10. And I'm going to solve for the x value that makes this true. So a little algebra here, subtract 10, you get minus 7 equals 0. A little factoring, what multiplies to negative 7 adds up to negative 6. Negative 7, positive 1, which means we have two solutions, 2 times when that h value will equal 10. However, keep in mind we've restricted the domain to x is greater than or equal to 0, so disregard the negative value, and we are talking about the x value of 7. Okay, so h of 7 is 10, which is another way of saying that f of 10 is 7. They're inverse coordinates of each other. X and y are flip-flopped. And so now what you want to do is find the derivative on h at that x value. So you found that it was at 7. Now you're going to take that 7 and find the derivative on h at that inverse coordinate, if you will. And that's easy enough to do because I have h, so h prime is a piece of cake, a little power rule here, 2x minus 6. And now h prime of 7, plug 7 into that. 2 times 7 is 14, 14 minus 6 is 8. And that's that. And now what our answer is the reciprocal of that, 1 over 8 in this case. And there we go. So if you are a person who doesn't need to sort of do this loop process, as I call it, even though you're doing all the same steps, just to recap, what we really just did here was we used this rule. And some people will just be fine thinking about it this way, that I wanted 1 over h prime of f of 10. And the first thing I found was f of 10 when I set that h function equal to 10, and I found that that x value was 7. You know, that's what you just found there. That's what f of 10 is. And then I found h prime of that 7, and that was 8. And so there's the value. So it's really a little 3-step process. I just like to visually represent it this way, like, hey, it's kind of a little detour to getting to what you really want. But hey, there's that example with algebra. And now I've got one more here just to drive this home and show you a slightly different way in which you may encounter this in AP in particular. It says, in the table below are selected values for the function f of x and its derivative f prime of x. So we got f prime at various x values here. And then they have given us this, that g is the inverse of f. So there's that inverse notation. Rather than showing you the composition property, this is another way to get across that they are inverses, right? It looks like, a -1 exponent, but we know that means inverse. Write an equation for the line tangent to g at x equals 3. So classic tangent line stuff here. If you want a tangent line to g at x equals 3, you need the point, g of 3, and you need the slope, which is g prime of 3. Once you have those two things, writing the tangent line should be a piece of cake. Of course, what's a little bit challenging is that you don't have g's, values on the table. You have the other function, the inverse function. So it's up to you to be able to interpret and pull these values from the table. So here we go. We're just going to think about it the same way here. The other function, the inverse function, is f. And how are these things connected? If 3 is the x value on g, then that means it's the y value on f, right? And so that's your first thought, is when, finding that inverse coordinate. When is 3 the y value on f? So you look on f, here are the y values, and that 3 is the y value when you're talking about an x value of 2. Okay, so right there, if f of 2 is 3, that means g of 3 is 2. X and y are switched, so there's your point of tangency, 3 comma 2. And as far as the slope goes, you're sticking with that same inverse x value and saying, okay, well, what's f prime of that same inverse coordinate? F prime of 2 is 5. And that tells me my slope, my derivative value, is the reciprocal of it, which is 1/5. So here's the two pieces of information you need, and now you should be able to write that tangent line. I'm going to use point slope form. Y minus 2 is equal to the slope of 1/5 times x minus 3. And there we go. And if you want to change it around to slope-intercept form or any other, equivalent version, that's great, but not necessary here. So, saw two different inverse examples. Hopefully this cleared it up a little bit. It can be a little bit confusing until you get the hang of it. So keep working. If you have any questions, just let me know.